Hi everyone, I'm in the engine room of the USS Jerome here in San Francisco. We're just across the bay from Alcatraz, and I thought this was an excellent opportunity to teach you about the characteristics of linear functions. Output R5.
Alright, so here we go. This is our R5. It starts with question 13. Hey look, it's about a flight from Beijing to Edmonton. Isn't that exciting? And we're just looking at this as a function flying from Beijing to Edmonton. And the distance here, well, it's showing the distance of the plane from Edmonton. So you notice eventually the distance by the time we arrive is going to be 0, and it started off with a distance of 9,000. Okay, let's answer these questions one by one. Determine the vertical intercept. The vertical intercept, that's 9,000. How do I know that? Or 9,000 kilometers? Well, let's take a look at the graph. The vertical intercept is the point where the graph of the function intersects the vertical axis. Next, determine the rate of change. The rate of change is equal to the change of the dependent variable divided by the change of the independent variable. And I can choose any 2 points on the graph in order to calculate this. I'm going to just look at the endpoints here at the start and here at the end. The dependent variable is the distance. This goes down by 9,000 kilometers. Now it's very important that we say it goes down by 9,000. It started at 9,000 and it ends here at 0 kilometers away from Edmonton. The independent variable, well, that changed by 12 hours. And this one's positive. As I go from left up here to right down here, well, time goes from 0 to 12 hours. So it increases by 12. Okay, if you calculate that out, by the way, 9,000 over 12 gives you negative 750 kilometers per hour. Moving right along here, write the domain and the range. Okay, the domain, well, the lowest domain value is 0 hours. This is measuring time. And the highest time value is 12 hours. So all the time values are between 0 and 12. The range, again, the least range value is 0. We're talking about distance, I believe, d. And the greatest distance is 9,000 kilometers. Okay, so there's our domain and range. Notice that it's written this way and not as a set of 0, 1, 2, 3, 4, 5, yada, 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 because it's every single value. Okay, what is the distance to Edmonton when the plane has been flying for 5 hours? Well, we'll have a better way of doing this later on in the course. But for now, let's just look at the graph. 5 hours is over here. We can connect up to the graph up here and connect across down here and take an estimate based on that. I'm not sure what that gives me exactly, but I'm going to estimate that to be 5,300 kilometers. 5,300 kilometers. Okay? This is an approximation, which I can write like this, for example, because it's not the exact amount. We're going to have to develop good ways of finding that exact amount sometime. Okay, last one here. How long has the plane been flying when the distance to Edmonton is 6,500 kilometers? So again, I'll look up at my chart here, 6,500 kilometers away from Edmonton. Connect this down and do it as a straight line, a little better than me. This is something after 3. How far after 3? I'm not really sure. Again, we have to still develop this in the course, but let's say it's 3 hours and 10 minutes. Okay, and again, this is an approximation. We'll develop better skills later on. Okay, and last question in this section is to sketch a graph. Well, for the x-intercept, this is when y is equal to 0. Well, if y equals 0, we have 0 equals 2x minus 4. I add 4 to both sides. And dividing by 2, I end up discovering that x is equal to 2. That's the x-intercept, is x equals 2, y equals 0. I can put that on the graph, say right here. But I should put a scale on there so that you know what I mean. This is 1 and 2 and 3 and so on. Let's do the y-intercept. For the y-intercept, that's when x is equal to 0. So for x equals 0, well, f of 0 is 2 times 0 minus 4, which is negative 4. So if x is 0, y is negative 4. I can put that down here. But that's not good enough. I have to remember to give you a scale. Minus 1, minus 2, minus 3, minus 4. Okay, connect the dots. A little better than I did here. Remember, I'm drawing on a tablet. Please don't judge me. Put arrows on the end and give us a label. We'll maybe give this a label of f of x. Okay, there you go. That's outcome R5. There's one more to go. I hope you're enjoying these.